Will our numbers be better this month? Can we improve our techniques and add additional assurance to our supply chain? If you're sitting there and have similar questions racing around your head, then we're really, really glad you decided to join us today, because we're going to be discussing specifically how upstream manufacturers can use data they have right now to help better forecast and improve their bottom lines. Hi everyone, my name is Christian George. I'm a marketing specialist here at Arkieva, and we're glad you decided to join us for today's webinar titled Loving Big Data, How to Avoid the Bullwhip Effect with B2B Demand Sensing. I'm joined by Arkieva's Chief Operating Officer, Sujit Singh, and he's going to lead us through a discussion on how upstream manufacturers can use data and techniques available to them right now to better forecast, improve their numbers, and add additional assurance to their supply chains. But before we get started, I wanted to just mention a few things. First off, if you're having any problems with GoToWebinar, if you can't hear us, if you can't see our screen, or just having another issue, please let us know by just typing in the chat feature, or you can also email me at cgeorge@arkieva.com. So if you could actually, people who are online right now, let me know if you can actually hear us. Just type in the chat. I'll give you a few seconds to do that. Okay. And at the end of the webinar, you also have a chance to fill out a quick survey. In this survey, you can give us feedback on how you actually liked the webinar and what we presented. So please, 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 we ask that you take 30 seconds to fill it out so we can continue to make things better for you guys. It's important to us that we're sharing information that will help you succeed as supply chain professionals. And we won't know if we're doing that unless you give us your feedback. So thank you in advance for completing that survey. So now I'm going to move into today's webinar agenda before I turn it over to Sujit. So first, he's going to introduce us to Arkieva, tell you guys what we actually do and who we are. Next, he's going to create a foundation for the discussion by defining both the bullwhip effect and demand sensing. And then we're going to get into some specifics about upstream manufacturers, mainly what data should you be using and how to use it better to predict demand and avoid the bullwhip effect. Next, he's going to give some examples of different demand scenarios companies may experience, and then he's going to tie it all into an example of how to implement B2B demand sensing at an upstream manufacturing company. Finally, at the end, we're going to save some time for questions. So please submit your questions in the question feature, and we'll get to as many of them as we can. Please, if you don't mind submitting, when you submit your question, identify yourself by role and company. It'll help us to create more context in the answer to the question for everybody else. So now I'm going to introduce you to Sujit.
Thank you, Christian. All right, so let's talk about B2B demand sensing. Hopefully in the next 40 minutes or so, we'll cover all of that. But let's begin right at who we are. And so both Christian and I work for a company called Arkieva. We have been in business since 1993. We have been completely focused on the field of supply chain planning right from the very beginning. And we have provided software and other technologies to help large manufacturing companies with their supply chain planning. In the early days, we were called supply chain consultants, and we rebranded to Arkieva in 2011. And in the course of our existence over the last 24 years, we have gone through multiple generations of our software, and right now we are on our 4th generation, which means that we have designed our software as the technology has progressed fully 4 times over the years. Our founders came out of the DuPont company, And as a result, we got started in the chemical and process industries. If you look at this slide, which includes a few of our clients' logos, the left-hand side is loaded with the chemical and process industries, and that points to the heritage that we have coming out of DuPont. Over the years, we have expanded into the food and CPG industry as well, which has a lot of similarity with the process industry manufacturing environment. And then we have also gone to discrete industries lately, where we are working with auto manufacturers and airline parts manufacturers and auto parts manufacturers and companies like that. When it comes to helping our clients, we do end-to-end sales and operations planning. And for us, that includes segmentation of the data. For example, helping our clients loading their data from their ERP and letting them know which are the big customers, which are the small customers, where there might be opportunities to have different business practices. We follow that up with demand. This is the idea of demand planning, where we do forecasting, and whether it includes the statistical piece of it, whether it includes the collaborative piece, where we collect input from different participants in the forecasting process, such as the salespeople. We deal with inventory, both the inventory targets and safety stock settings, as well as the planning out into the future as to where the inventory should end up, the projected inventories. Supply planning, where should we make the product, where should we buy the product, when should we make it, when should we buy it, followed by the support for the S&OP meeting itself, which we call the S&OP management. Today's session, as we are calling it, is demand sensing, and it fits neatly under the box of demand planning. So that's what you see in this picture. All right, so now let's get started with today's topic, and let's begin with this pictorial. If you would just pay attention to the rightmost side of this picture, where we have customers, and let's work our way backwards to all the way to the left. So if we think of the customers as the consumers of a product, whether it's you or me buying a particular soap at the shelf of a retail chain, and if we work our way backwards from there, the demand exerted by you or me is the ultimate demand for that product, which then leads to stores trying to determine what that demand ought to be, and then stores then express their demand on their regional warehouses from where they get the product. And maybe not so much in the case of soap, but in some other cases, there might be an assembler behind the regional warehouse that puts the products together in the packaging, which might then go to a module manufacturer, which might then go to a parts or an ingredient manufacturer. So if you look at it from the consumer end, the rightmost end, and work your way backwards, you see about 6 or 7 steps. And depending on the industry you are in, and depending on the products you sell, you might be 2, 3, 4 steps removed from the final consumer. When we have a chain of this length, everyone tries to protect themselves by keeping inventory. And these inventories are to hedge against any kind of variability in the supply chain. As a result, what we see is that huge buffers of inventory exists between the customers and the prior step, and the prior step from the step before that, and so on. And in fact, some studies have shown that across this very long 6, 7 step supply chain, up to 6 months of total inventory can be residing between the step of the consumer or the customer and all the way back to the ingredients or the part manufacturer. So that's a lot of inventory. Why does that happen? Well, let's introduce this idea of the bullwhip effect. Now, as the name suggests, it takes its name from the actual bullwhip, and the idea is that if a person gives a little nudge to the whip, or whips it, as you would say, then the part closest to the handle will have just a very little bit of movement, but parts further away would move quite a bit, and the movement increases as we get further and further from the handle. In the supply chain world, this idea, it can be related back to the thinking that the consumer or the customer is the handle, if you will, and they create a little up or down movement in the demand, which then travels up the supply chain. And as you get further and further away from the consumer, you see bigger and bigger waves or movement, and that's what is described as the bullwhip effect in the supply chain space. I'm not going to get into a very detailed description of it. There are certainly books written on it, and it's easily available on the web. But let's just say that this effect has a very strong effect on the different upstream manufacturers, in the sense that the inventory that they have to keep to deal with this increased movement or the increased amount of uncertainty leads to higher and higher levels of inventory. If we were living in a perfect world and all the data was being transferred completely without any kind of confusion, then one could argue that all of this extra inventory in the supply chain could decrease. So let's summarize it, that the bullwhip effect ultimately causes upstream manufacturers to have an increase in uncertainty, which therefore results in lower forecast accuracies, and then as a result, higher inventory levels. Now, let us define the other term, the demand sensing. So traditionally, if you think about a company that is maybe one step removed from the retail store, well, they can get a very nice feed from the retail store. In this day and age, that is very much possible to do using the internet. And if you get a data feed which shows you the POS, the point of sale data, as it is registered on the cash registers of that retail store, if you can get that data at some routine level, then you can use that to do demand sensing, and you can try to see if your demand is going up or going down, or is it higher at a particular hour of the day, and you can use all of that to improve your forecast accuracy. Now, point of sale data is just one way you can do demand sensing. There are other ways as well. You can, for example, these days there's a lot of talk about market buzz. People are scouring the comment section of different websites to understand what is the buzz about, what does the buzz sound like for their products in their respective marketplaces. But POS seems to be a very well-established way of doing demand sensing. And there are two main reasons companies do this. Obviously, they want to improve their near-term forecasts, and they want to see if any demand shaping is needed. What is demand shaping? Well, that's not the purpose of this webinar to go into a lot of detail, but at a very high level, if we can undertake certain activities to increase or decrease our demand knowingly, then that is something you would call demand shaping. So a promotion, a buy one get one free promotion, or a price reduction, or a price increase if you want to really decrease the demand, those would all be examples of demand shaping. The second main reason companies like to do this is to create an early warning for forecast errors. Let's say, for example, I was all gung-ho at the beginning of the month and I had forecasted that I would have a blockbuster month. As I begin to do some demand sensing, if I get the sense that I'm not really going to hit those numbers, maybe there are certain actions I need to take. Maybe I can go back to the demand shaping idea and create promotions to sell the product. Or if my product is not already manufactured, maybe the thing to do is to reduce or slow down the production of the product, so that even though it's still going to hurt, maybe it's not going to hurt as much because I had a good chance and I actually took good actions to prevent the bad effects from my slow demand. So those are two main reasons companies do that. Okay, so if you're close to the retail or to the consumer in your supply chain, then obviously you have access to the POS data and you can use that very meaningfully. But if you are upstream manufacturer, so you are not the person who makes the soap, but you make the chemical which goes into some other chemical, which goes into some other chemical, which ultimately is part of the soap. And you can, think of other examples like that. Well, if you're such an upstream manufacturer, then what can you do? Obviously, for you or for someone who is a part of this upstream manufacturing, the POS data is either not available, certainly not very reliable once it passes through 2 or 6 steps, as the case might be, and you could argue not very applicable because of all these other buffers that companies in the middle hold for you. So even if by some luck you were able to get the POS data, you would have a very tough time translating that to any supply chain action. And the volatility and the uncertainty are quite high, resulting in, can result in very high supply chain costs via the bullwhip effect. So then the question arises, can any other data stream be used to do demand sensing? Well, the answer is yes. And the answer is we can use a data stream called the open orders history to do this. So let's look at that and how we would do that. All right, so let's begin at the basics. If we want to implement, or if an upstream manufacturer wants to implement the B2B demand sensing, what would they need to know? Well, they would need to know that they can capitalize on open orders data as a substitute for the POS data. And they might actually be interested in this idea of the market buzz, the idea of the long-term market shifts. All those things can have a very significant play in the idea of demand sensing. Now, in today's discussion, we will focus on the open orders and looking at it as a substitute for the POS data. For some of these other topics, we will do more webinars later. In fact, our partner Solventure has a very good webinar which you can look up on their website, and this is a webinar on forecasting using economic indicators. So we will focus primarily on using the open orders data as a substitute for the POS data and using that for demand sensing. All right, so before we jump into the open orders, let's look at what companies, or many companies, let's say, do already. And there's one thing that companies do already, and that is the sales pattern analysis. And this very simple idea that they like to understand, what part of the month does their demand come in? Does it come in early in the month? Does it come in, basically like a flat line throughout the month and so on? So, while it's certainly possible to take a straight line and draw a very, across the month, a very straight line the way I'm drawing right now. But in general, companies' data comes in in a different way, and you can see that in this schematic. Let me just get this drawing tool out of the way. This schematic, the graph is showing us the percent split of the demand that is coming in. So if you look at this example, approximately 3% of the demand for this company comes in on the first of the month. Second of the month is no different, then it drops to about 2%, then it goes up to 4%, and so on. So on a daily level, we can see how the demand has changed on a percentage basis. And you can create a profile like this from your existing data, and you can look at your data, you can mine your data month over month to get some kind of an average number. Because during any given month, the first of the month will not exactly be 3%. It would be 3% in some months, and it would be 4 or 5% in other months, and it could be 1 or 0% in yet another month. So once you take the average, you might be able to get a sense of where it is that the first of the month lies. In fact, if you understand the theory of the law of large numbers and small numbers, you might actually eventually walk away from doing this on a daily basis, and you might do this type of analysis on a weekly basis, because day-by-day fluctuations might be too much, and you might want to do this in somewhat bigger buckets to say how much comes in the first week, how much comes in the second week, how much comes in the third week, and how much comes in the fourth week. So that's one example. Another example could be dealing with weekdays. So you might have a company where the demand doesn't come in on every day of the week. So here is an example where the distribution is very clearly leaving out the Saturdays and the Sundays. You are seeing a lot of demand on all other weeks, and then there is a pattern. The first Monday is not as strong as the second Monday, is not as strong as the third Monday, and so on. You might have demand that is very front-loaded. You might have certain characteristics in your supply chain that all the demand happens to come in the beginning part of the month. I'm sure that there can be actual actions that you might take as part of your supply chain activity that can drive a customer to do that. In fact, in that regard, the next example is quite common. You might have demand that is coming in towards the end of the month, and this is where companies provide, for example, a lot of incentives for companies to load up at the end of the month, and we can kind of coach our customers into bad behavior. And here's another example where the demand is in the middle of the month. There is nothing magical about a month. You can certainly do the analysis on a weekly level. So here, if you are in the restaurant business or, retail business, you might actually want to look at the data in a weekly level. Of course, an upstream manufacturer in certain industries can also have a need to look at the data at a weekly level and try to understand the order pattern within a week. So in this example, Thursdays are much stronger. Thursdays are the strongest day, followed by Friday, Saturday, Sunday, and then Mondays are weaker. Obviously, as we do this analysis, let's recognize that this data, the examples that I've shown you, are just that. They are samples, they are examples. In fact, the number of permutations, combinations that exist are infinite, and really, depending on your business, you might have your own profile that you work out. So companies will do this kind of linear projection where they will take the in-period demand, the actuals, the green bars in this graph represent the actuals, and then the yellow bars represent the open orders. And then what they are trying to do as the month goes by is they are trying to stack up the actuals that have already happened month to date with the projected numbers, which are the yellow bars, and trying to see where they will end up with respect to the forecast, which is represented by the blue line in this graphic. So the blue line is something that they established as the forecast, and as the month is going through, they are trying to understand where will they end up at the end of the month. Are they going to be slightly above, slightly below, significantly above, significantly below the projected number? And they use this information by the time the 10th or the 15th of the month rolls around. They use this information to fine-tune their forecast, or at least stop doing any further harm. If the product is running really slow, they might not make any more of it. If the product is running really fast, they might make a lot more of it. Companies will use this type of analysis to do what is called the gap to yearly goal, where they will take the numbers and plot it. If you look at this graphic, the first 4 data points till April are historical, and then May to December are the planned or the forecasted numbers, and they would compare that to what they have established as the budget. And if you look at the columns at the bottom, those are the delta numbers. Those represent whether or not you are meeting the budget numbers. So if you can see this picture, the company started the year a little bit behind the budget, and then over time, that gap gets closer and closer based on the future forecast. Whether that actually happens or not will only be known as we get closer and closer to December, but this provides them a way to create an early warning about whether or not they are going to hit the budget numbers. Right, so what do they do with this data? I mean, when you have the actuals coming through, basic math is very, very simple. They are calculating period ending projections based on the actuals. So if they know how much sales came in on the first of the month, and I'm talking about the first row of the table, well, then multiplying it by 30, which is a very simple 30 divided by 1, gives them a sense of where will that month end up, as long as they assume a steady demand. If they assume a steady demand, but they know that they only sell on weekdays, well, then in that case, assuming 21 days, they would multiply by 21 and get a sense of where that month will end up. The middle column, though, is somewhat interesting, because if your demand is up and down, it's not steady, then that multiplier of 30 is no longer applicable, and you would have to do some math to calculate where you will end up. And that is that factor will change through the different types parts of the month. On every single day, on a steady demand basis, you can have a very simple multiplier, but on a variable demand basis, it can be calculated. So let us now switch gears and talk about how open order history can be used for more. Now, we are going to make an assumption that in order to do any of this, any of what I'm going to talk next, one would have to collect open orders history on a day-by-day basis. Now, given that where we are technologically, almost all manufacturing companies have an ERP system, so open orders are being recorded in the ERP system. But not all ERPs will have a history of the open orders. And what we mean by a history of open orders is we would like to capture the open order file as of a particular day. So we would like to see the open order file as of March 1st and be able to compare it to the open orders file as of March 2nd and being able to compare that to the open orders file as of March 3rd. This is a relatively data intensive exercise, and obviously it will lead to a lot of data. Well, once you have that, and maybe your ERP already has this information, in which case you're ready for the next steps. If not, you might have to wait some time to collect all this data. Once you have that though, you can take your open orders as of a particular day and compare that to how the month ended up. So let's look at this example. Here we have collected the data on March 15th for the month of April. This is all in the past. And so for the month of April, the open orders for the month of April as of March 15th were 1,000 units. And by the time April ended, we had sales in April of the amount of 2,850 units. And if we do a very simple mathematical ratio, then that tells us that March 15th open orders for April, when multiplied by the ratio of 2.85, which is 2,850 divided by 1,000, would have given us an estimate for where April will end up. We can do the same thing for 16th. For the 17th, obviously the ratio will go down on a day-by-day basis because we have more open orders and the end of the month is not changing. On that basis, the ratios go down. By the time we are in the month of April, on April 5th, we already have open orders worth 1,900 units. And when we compare that to how the month of April eventually ended, we get a ratio of 1.5. So we can do that for any month. Well, when we do that for any month, we have one data point, and what I said earlier, if you want to increase your reliability of that ratio, you need to take many, many data points. So how do we determine a reliable predictor ratio? Well, let's repeat this analysis for the 15th of the month going back last 18 months. So in this example, we do this analysis in March and how it predicts the month of April, and we get a factor of 2.85. Then we repeat that in April, and we get a factor of 2.8. Then we repeat that in May, and we get a factor of 2.9, and so on. And eventually, if we have 12, 15, 18, 24 data points, then we can calculate that on average, 15th of a particular month, the open orders in the books as of the 15th of a particular month can predict the next month on average with a multiplying factor of 2.82. And oh, by the way, there's a range associated with it. This comes in because this is a lot of numbers, so we are dealing with averages, but we are also dealing with standard deviations. So there is a range which is 2.7 to 2.9. So now this tells us that as of a 15th of any particular month in this company, the prediction for how the next month will end up has a multiplier of 2.82, but that multiplier also ranges from 2.7 to 2.9. So it's not a point estimate, it's a range estimate, with the most likely estimate being the middle of that, which is 2.82. So if we now take this idea and just generalize it, so instead of saying just the 15th and so on, we now say, let's think of it in terms of M0, which is the current month, and M1, which is the next month, which is the one we are trying to predict. And so if 15th of M0 gives us a prediction value of 2.82, which with a range of 2.7 and 2.9 to 2.9. The 25th gives us a much better, it gives us a different average, but much tighter range. The average is 2.19, but the range has tightened to 2.10 to 2.25. So the first range was about 0.2 wide. This range is only 0.15 wide. By the time we reach the 6th of M1, our average has dropped to 1.45, and our range has tightened further to between 1.4 and 1.49, which is only a gap of 0.09. And of course, by the time we reach the 20th, almost all the data is in, and at that time the average predictor ratio is very small and the range is also quite small. So this analysis we can do, and as long as we repeat it over multiple cycles, we get this idea of what that average predictor ratio and the range for that predictor ratio is. Of course, when we get closer and closer to the end of the month, the prediction ratio gets better because we have almost all the data. Keep in mind that even though we are talking about open orders, we are actually adding in the actuals into that. So as we get closer and closer to the end of the month, we will have the actuals plus the open orders will actually be quite close to where the month ends. For example, just to be totally clear about it, on the 29th of the month, we have shipped almost all of what we are going to ship on during the month, and we have 1 day left, and all the open orders in the books probably represent all that we are going to do. We are not going to get brand new open orders very likely on the 30th of the month to be shipped on 30th of the month. So to take a rather extreme example, on the 29th we almost know with 100% accuracy how the month will close. Well, as we walk backwards from there, on the 25th, on the 20th, and so on, our projection is going to be quite tight simply because most of the data has come into the system by then. And that's the idea that I'm representing in this slide, that the prediction ratio gets better and better as we get closer to the end of the period in question. So let's put it all together. So we have now done some simple math and calculated these predictor ratios. Before doing the calculations, we did some tedious work of collecting all the data, and now we have the averages and the ranges available to us, and we can use this to plot our predictions and do some demand sensing. So here is an example. This is an output from the software, so you can certainly do this type of thing in Excel or any other charting program that you have. So in this example, at the bottom here is the green line, and that represents the open orders. The green dotted line, the green solid line at the bottom represents the deliveries. The dashed green line represents the open orders, and then the blue line represents what we forecasted for this month at the end of the previous month or previous cycle. And then this data is as of the 3rd of the month. So as of the 3rd of the month, we can see what our projection looks like for where the month will end up. The red dashed line is what you call the average prediction, the most likely estimate, and then the gray area is representing that range, the possibility that our estimation might not be exactly right, it might only be directionally right. So as you can see in this schematic, the range is quite wide, and even though the range is wide, we can still say that as of the open orders available to us at this point in time, which is the 3rd of the month, our forecast is going to be beaten by the actuals by 1 million units. Our forecast is, half a million units. Our forecast is about 11 mil, and this looks like about 500,000 units above that. If we roll this forward, and now we are on the 6th of the month, so we have at this point a few more deliveries, so you can see the graph has moved along. It seemed we got a bunch of new open orders. You can see this inflection in the graph, so there has been an uptick in the open orders. As a result, our projection has turned as well, and now we are projecting quite a bit more than what we were projecting on the 3rd back here. And this ratio then says that we will be about 2 million units more than what our forecast was, and we will end up at about 2 million units higher. By the way, a point worth noting is that on the very 1st of the month, this had already projected a number quite close to the number that it's projecting now on the 6th. It took a dip, but then it has come back. So one can argue that the predictor ratios at the beginning of the month were quite strong, and this was just noise that we had in this particular month. And the other thing I would point out is that the range has narrowed. The gray area is not as wide as it was on the 1st of the month. Let's move this graph a little bit forward. Now we are on the 9th of the month, and you can see the red line has progressed nicely. It's come down a little bit, not as much as when it was on the third, where it was on the third, where it was in a big dip, but it's come down from where it was in the previous check. The range has narrowed. We have made more deliveries. We have gotten some more open orders. Thing to note is that, and this is true for a lot of upstream B2B manufacturers, the open orders have started to stabilize. We are not getting this line is not really trending up anymore. So this tells us that a lot of the open orders might actually be in by the 10th or the 12th of the month. Let's keep rolling. Here we are on the 12th of the month. Again, the range has narrowed. Our prediction is still in line with where we were. It's not as high, but it's not as low. It's somewhere in the middle, still about 500,000 units above the line. And as I said in the previous slide, the open orders have stabilized and they have not really moved a whole lot. And if we take this now quite a bit forward on the 21st of the month, well, as you can see, the range has narrowed considerably. Well, that is obvious because we have a lot more data at this point. Open orders have completely stabilized, and we are now beginning to see very clearly where the month will end up. And then if I take this almost to the extreme, then on the 27th, really there is no doubt. The range has basically disappeared, and the open orders and the projections basically line up with each other, so we know exactly where this month will end. The key thing to note is that we are still above the forecast by a considerable amount, and which, by the way, was almost predicted exactly or correctly in the beginning of the month. So think about a manager who puts out numbers to the appropriate upper management to say, here's how my business would end up. And at the beginning of the period, whether it's month or quarter or year, you are able to take this type of information and project it to say, look, I already know that we are not going to hit our target. We are going to be over or under based on these other data points that I'm collecting. And that is the basic idea. And you use this to sense your demand and then take appropriate actions. So let's summarize all of this and we'll then take some questions. So in this whole analysis, we are kind of taking the open order history and replacing that as the data feed that is called the POS, or the point of sale data. And we are trying to get to that same kind of demand sensing effect through the open order history. And you know, as I said earlier, there's a lot of data involved, and also there's a lot of uncertainty involved. So this becomes a game of data and probabilities. In this example, certainly, if you look at the graph on the smaller screenshot of the graph, our earliest projection was almost the same as where the month ended up. So there's some value in this data point. If you're familiar with the idea of triangulation, well, when we generated the forecast, we had one line of thinking going in. Now we can take this open order data stream and generate a totally different line of thinking and use that to project where the month will end up. So this allows us to understand whether or not we will hit this forecast early, and this obviously can drive actions. And last but not the least, the reliability of these results will depend on data. Small volumes of data will have very unpredictable and certainly very unreliable results. In fact, I was recently reading up on a study that they were trying to isolate the number of incidences of a particular disease in a rural area. And what they kept finding was that each survey results, the findings would just, sometimes go in the opposite direction. And after a lot of research, what it boiled down to was that in these rural areas, their sample size was so small that their predictions were completely unreliable. So let me just use that example to say to you that if you are going to indulge in this whole exercise, just remember that you have to work with large volumes of data. You need to get your open order history over the last at least 12, if not 18 to 24 months. Which gets us to the realm of big data. I mean, open orders in any company, the amount of line items of open orders can be quite large. And if you are now beginning to store that on a day-by-day basis, you have a lot of data, and it can potentially, depending on the business you are in, cross into the realm of big data. And you will need tools to keep that. Probably, if you want to do all of this in Excel, one could argue that you might have too much data to deal with. And Last but not the least, always remember that in all this analysis, because of the statistical nature of the analysis, there is always an average, or what we call an expected value, and a range, which basically is a very nice way of saying that no matter how good a job we do, the prediction will have some error baked into it. So as long as we remember that, I think we will be fine. So with that said, I think I'll turn this over to Christian and to you if you have any questions.
Yeah, great. Thank you, Sujit, for walking us through the discussion. And please, like we said previously, submit your questions. We did receive a couple that we're going to go over. We'll try to get to as many as we can. So the first question we have is, how could B2B demand sensing help us improve on-time deliveries?
Great question. So, if we knew exactly what our customer is going to be needing from us, all of us probably would be prepared to deliver that in a timely fashion. And while there is no magic to it, obviously things can go wrong in a supply chain. Forecast is a key element in doing this on-time delivery because it allows us to be prepared to have the right products in the stock at the right location. And so this B2B demand sensing, the whole idea is that it provides you a way to triangulate, to sense the gaps between what you projected and what actually is happening so that you can improve your forecast. So as you improve your forecast, you then get better prepared, and as a result, your on-time deliveries get better and better.
Great. The next question comes from Steve at Hexion. What level of aggregation is typically used?
Great question. Because of what I said earlier, that this whole exercise is about data volumes and getting reliable statistics out of the data, if you do this at a product level, and if that product gets one order per month, obviously you are not going to get any reasonable estimation. And so the key thing is to choose a level where there is a lot of data. In some companies that I work with, this can be down to the SKU level. In some companies that I work with, this is down at the bulk product level, meaning SKU minus the package. In some companies, this can be as high up as product family level. In very rare cases, I've also seen that this can only be done at the overall company level because they just don't have the open order volume to do it at a very detailed level. So the answer, unfortunately, depends on the business you are in and how much data volume you're dealing with. The only golden rule here is that any statistics derived from low volume of data will be unreliable and should not be used.
Great, thanks, Sujit. Next question comes from Mark. How does this method avoid not seeing demand from multiple stages away in the supply chain?
I don't know if I completely understand the question, but to the extent I do, in this case, the open orders are primarily coming from your customers, and we are saying that open orders are slightly more predictable input towards the demand compared to, for example, the forecast that we generate. So open order is something that the customer has already decided to buy. I'm not talking about blanket orders. I'm not talking about something that those are done or a volume discount type of thing. I'm talking about an actual open order placed by a procurement person into the CSR. And that is a very, very strong indication, a very, very strong buy signal. And it has accumulated knowledge in there about what the previous steps in the supply chain are doing. And as a result, that has isolated, it has taken out, let's say, all the fluctuations that come in from all the other elements, and it's very focused on this particular company's supply chain. So in that sense, I do believe it isolates the input directly from your customer, and it tries to weed out the disturbance that comes in from further down the chain. Or you can say, if it doesn't weed it out, at least it has assimilated it to a level where the customer is actually willing to make a commitment towards the demand. So in that sense, I do think it weeds it out.
All right, and our final question for the day. will be from Joe, and Joe's from SPI Pharma. The open order data you refer to, is it based upon order entry date or ship date at time of order entry?
Okay. So when we get an open order, or when we get an order from a customer, especially in the B2B environment, you certainly can be in an industry where the orders are for the same day. But generally speaking, open orders are being placed where they say, I would like 1,000 units of such and such product on such and such date. And by the way, depending on the industry you are in, that date could be the delivery date or could be the ship date. And so what I'm saying is, now this order is an open order in the books. It is due, let's say 10 days out, and it is recorded in the system today. Well, this order will remain an open order tomorrow as well, and it will remain an open order the day after that as well. So what we want to capture in the file that keeps the open order as of today, we will have this order with the delivery date of 10 days out. In the file that shows us the open order as of tomorrow, this order will still be there, but the delivery date will be 9 days out. And the file that shows us the open order, day after tomorrow, will still have this order, assuming that we have not shipped it already, and it will now be 8 days out. So that's what I'm talking about. It will have the ship/delivery date, depending on the business you are in, but we want to capture the fact that this order file extract is as of what date. That's the extra column, if you will, that you will need to add into your table.
Thanks, Sujit. We actually do have time for one more question. This comes from Lipping. How do we decide which level the predictor ratio is calculated at? When the predictor ratio is calculated, it is based on the loading pattern. How much historical data is used to decide the loading pattern?
Okay, I think this was similar to a question from Steve, where where we said the level at which the decision should be made. Like I said, the golden rule is that you want to make this decision at the level at which you have a lot of data. You do not want to make it at a low level where you only get 1 or 2 or 5 orders per month. You want to have a reasonable size. For that reason, also, I suggested that you should look at a lot of history, 12 to 18 to 24 months. The other part of the question deals with when the prediction ratio is calculated, is it based on the loading pattern? Well, let me tie this back to Joe's question from a minute ago. Whether you use this on a loading pattern, which I loosely will tie to the ship date, or to the delivery pattern, which means when you deliver the product to the customer, will be different for different companies. There are companies who, in their ERP system, do not record the delivery date when they take the order. They only record the ship date, or which should be very close to the loading date. And there are companies that record in their open orders only the delivery date. Maybe there are companies that do both. I certainly have not seen a whole lot of that. So depending on which field you record, this analysis will be done based on that. I wouldn't worry too much about that only one is correct. The main thing is the field that you are recording on the open order, whether it's ship date or the delivery date, you will need to understand that clearly, and then you might have to adjust your analysis if it is delivery date. My examples assumed that the data had the ship date in it. If you were actually capturing the delivery date in your open orders file, then your data feed will need to be adjusted to account for the lead times. So that's a slightly long answer to the question, but unfortunately, like in a lot of these cases, the answer does depend on your unique circumstances.
Thank you, Sujit. And thanks to everybody who submitted questions. I know we didn't get to a couple, but we will respond to you within 48 hours offline. So stay tuned for that. So moving right along, what is next? So if you want to learn more about this topic or any other supply chain related topics, visit us at arkieva.com, or you can visit our blog at blog.arkieva.com. Once you get to our website, you can see in the top right-hand corner, there's a tab called Resources. Just hover over that, and you can find our collection of content, our content library, white papers. We have product sheets as well as case studies. So please, check those out. Also, if you'd like to request a demo, if you're interested in learning more about Arkieva's supply chain planning solutions, just visit our website as well. You can click that demo request button up on the top right-hand corner, or you can go to the URL that's mentioned right there, arkieva.com/request a demo. You can also just email me, cgeorge@arkieva.com, and we can have a further discussion offline. Finally, some dates to save. As Sujit mentioned previously, our partners in Europe, Solventure, they're having a webinar this Thursday, February the 16th, starting at 7:30 a.m. Eastern Standard Time. The topic of that webinar is going to be product management review as an important part of your SIOP process. To register for that, you can visit their website found right there, solventure.eu. And then next up for us, we have a webinar coming up on Wednesday, April the 12th. This one's going to be at 11 a.m., so make sure you note the time change. It's going to be 11 to 12 a.m. East Coast time. And in that webinar, we're going to be discussing using data analytics for B2B demand generation and shaping. So the follow-on to this conversation. Well, thank you again for joining us. We're really excited to get this started. And on behalf of Sujit and the entire team here at Arkieva, we'll see you next time. Thanks again.